Hello. In today's video, we will leverage a myriad of tools and techniques to run exploratory data analysis focusing on South African crime. If we had a purpose for this project, I noticed three: to further one's knowledge, to analyze, validate, process data, and offer unbiased information, and finally, to potentially use as a foundation for a larger, more in-depth project. Now, South Africa, officially the Republic of South Africa, is the southernmost country in Africa. Finally, we get to see some actual code. All I'm doing is from ipython.display, I'm importing the Python module just so that I have the ability to display the image you see on screen right now. If you aren't aware, this is the map of South Africa, which contains in itself 9 provinces: Eastern Cape, KwaZulu-Natal, Mpumalanga, Limpopo, Northwest, Free State, Northern Cape, and finally the Western Cape. What data will we be using, or where will we be sourcing our data from? We'll be sourcing our data from data.openup.org.za. And here's a description. It is crime stats of South Africa for the year period beginning 2011 and ending current year 2023. Now obviously the year isn't over, and this data was last updated June 21st, 2023. The data itself consists of 8 sheets. It will be an Excel spreadsheet with 8 different sheets, so a lot of data. Here are additional informations. Here is the source of the data. We notice it comes from the saps.gov.za. SAPS, I believe, is South African Police Service. We have the original author, Carl Jacobs, and the maintainer, Carl Jacobs. So again, this is where we will be sourcing our data from. Here are a few helpful modules that we'll be using to make our work a lot easier. Let me zoom in. There we go. To make our work a lot easier: NumPy, Pandas, Seaborn, and Matplotlib. For Matplotlib, I did alter some of its base settings just to make things a little better. Or should I say, better suited to my preferences. We'll then import the OS module just so that I have the ability to work with my current directory. I'll then run a for loop for file in os.lister, so the current directory we're in. If the file ends with xl.xx, we'll print the file. And when we run this, we get back crime stats all 2011, 2012 to 2022, 2023. This data year period is in financial years. If you aren't aware of what that is, I'll cover that in a few minutes. To work with Excel sheets, I will import the Python module OpenPyXL, which I'm doing in line 6. I then read in the entire file. I'll store it in some variable called xlsx. If we print out what type is xlsx, we get back a dictionary. And because it is a dictionary, we can iterate over it and print out the keys. Notice we have 1, 2, 3, 4, 5, 6, 7, 8 keys in our dictionary, which signifies the 8 sheets of data. If we just go over the keys, we notice we have crime incidents by category, and the remaining 7 sheets are all individual crime categories sorted by incidents of category. Now, let's just grab one of the sheets. We'll choose the first sheet, crime incidents by category. We will load it into a data frame called crime incidents _ raw data frame. The reason why I'm calling it raw data frame is because this is the raw data. There has so far been no alterations on our part. Now that we have our data, let's just look at the data. And we'll get rid of this head column. And here we go. Okay, never mind all of this. Focus on the bottom. We have 840 rows and 4 columns. By 840 rows, it means we have 840 instances of data consisting of a geography, a crime category, a financial year, and a count. If you aren't aware of what financial year is, it's usually used in the sense of, say, 2011, January will be the opening, and February 2012 will be the closing. So if we read this 2011-2012, let's just say it's January 2011 starting, February 2012 closing. Now let's come down here and determine if there are any NaN values. We will chain the isNA and .sum functions. And if we run this, we notice we get back no NaN values in any of the columns, which is great. Our data is very well kept. Now, let us use the .unique function to grab all unique geographical locations. And if we run this, we notice we get 10 locations. We get ZA and the 9 provinces we have covered. So what is ZA? So South Africa is SOUTH here, South Africa. But because of the Dutch imperialism way back when, the name stayed as Zuid-Afrika. That's why you see ZA. Again, if you see this column, if you see this appear anywhere, it means South Africa. And if I were to be a betting man, I would say the ZA geography is the aggregation of all other 9 provinces for a given crime category for a given financial year. Let's go over it one more time. ZA is South Africa, EC is Eastern Cape, FS is Free State, GT is Gauteng, KZN is KwaZulu-Natal, LIM is Limpopo, MP is Mpumalanga, NW is Northwest, NC is Northern Cape, and WC is Western Cape. Let's now just grab the geographies and run the .value counts method on it. And we notice we get a very interesting equal spread of data, where each geography has 84 incidents in our data frame. I needed coffee, but now I'm back. All right, so as I said, we have an equal spread of data, where each geographical location has 84 instances in our data frame. 84 times 10 is 840, which we confirmed is the number of rows in our data frame. So great, things are adding up. Let's now determine all the unique crime categories in our data frame. And to do so, we will grab the crime category column, all of its instances, and run the .unique method. This will return an array consisting of only unique instances of data. And we notice we have 1, 2, 3, 4, 5, 6, 7 columns. Contact crimes, sexual offenses. Did I count that wrong? 1, 2, 3, 4, 5, 6, 7. Okay, yes. Sexual offenses, aggravated robberies, contact-related crimes, property-related crimes, other serious crimes, and finally, crimes detected as a result of police action. Now here's the thing. This data, as I said, is from 2011 to 2023. These first 6 categories, 1, 2, 3, 4, 5, 6, hopefully we see a downtrend, because obviously we would want crime to decrease. As for this last category, crimes detected as a result of police action, is something that you either want to see stay static, increase to some point, and also decrease over time if the other 6 decrease. And why is that? Because this last category, crimes detected as a result of police action, shows an active police force, which is something we would want, regardless of location. We notice the D type or the data type for all of these is just an object. Now, if I grab the crime category and I run the dot value counts, it will give us all of the unique crimes and their associated number of instances in the data frame. Now, when I originally ran this function, I was flabbergasted. Why do I have 120 instances for each one? It adds up, but I still am a little confused. We'll get into this in a while. We notice each geography has 10 instances of each crime category for each financial year, with the associated number of occurrences of that crime for that given year. Let's grab the financial year column and run the .unique function. We get back all the unique financial years that appear, beginning 2011, 2012, ending 2022, 2023. And then I make a little comment here. Should be 70 each, as we have 10 unique geographies with 7 unique crime categories. Therefore, 10 times 7 should be 70. And in fact, if we grab the financial year and run the dot value counts method, we do in fact get 70 for each financial year. Alright, we're getting a very good view or good understanding of what our data is. Let's just look at a single row. We'll use the dot location member and grab the first instance using the 0th index to give us the geography of ZA, which is South Africa, the crime category, which is contact crimes, the financial year, which is 2011-2012, the count, which is 615,935. What I would say is this crime category, contact crimes, and the financial year and the count will be the aggregate sum of all other provinces, or should I say all provinces, for the given year 2011-2012 for the crime category to give us 615,935 for the geography ZA. Now, let's just grab the first 2 rows for reference. Ignoring the index, we have geography, crime category, financial year, and a count. How about this? Let's run a little code that will grab data only where geography is equal to ZA, so South Africa, and the financial year is equal to 2011-2012. And then we'll grab the first instance and we'll grab the count, which will give us 615,935, which is same as the value here. Okay, great. And that is how we filter our data to meet specific specifications of our liking. In this case, I wanted data where geography was equal to ZA, so here we have the geography ZA, and the financial year must be 2011-2012, so this financial year, and then I grabbed the first instance of that data. And finally, I grabbed the dot count column, or should I say the count column. Let me remove these last 2. And now if I run it, here we go. We see we get 7 instances. The 0th, 100, 200, all the way to the 600 index. And for the geography ZA, the crime category for financial year. So when I do this dot loc and I pass in 0, it will grab the first instance, so this one, this entire one. It should grab that. And then when I do dot count, it will grab the dot count column. And we get back 615,935. Again, that is how we can filter data to meet specifications of our choosing. This is essentially a SQL query if you are familiar with SQL. Now let's come down here. Now I only want to grab data where geography is equal to ZA and the financial year is 2011-2012. And if we run this, it's the same as the above when I had removed the .loc and .count. And this is all the data. You can just have a good look at it. We can look at some things. We notice that the lowest number of crimes committed would fall under the crime category of sexual offenses for the financial year 2011-2012, which was 60,539. And the highest number of crimes for a given category was contact crimes with an associated count of 615,935 instances of crime. Here is another comment I made. I would expect the financial year and the associated count for the South African geography to be the sum of every province for that same year and index. Now, how can I prove that? I'll filter the data such that geography is not equal to ZA. In this way, I will grab all of the provinces and I will not grab anywhere where geography is ZA. I will then choose a financial year. I'll choose 2011-2012 and I'll just choose a crime category. In this case, the crime category I chose is contact crimes. Let me get rid of these last two parts. And if I run this, here we go. We notice we get 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's all the 9 provinces that we have covered for a given crime category, contact crimes, for a given financial year, and their associated count. So once I do that, and if I grab only the count column, and then if I sum it, and if I run that, look, I get back 615,935. This means my theory is confirmed. We now know that the South African instances, or the rows where the geography is ZA, is an aggregate for the crime category for the given financial year. Cool, we are making a lot of progress. We are understanding our data even more. If all of these are flying over your head, don't worry. Things get much easier when we begin visualization. Also, this video will be done in parts because there is a lot of data. Here I'm just calling the data frame just so that I can remember what we're working with. Again, 840 rows and 4 columns. So, what is our analysis and inference thus far? We can very confidently say our data from the sheet, crime instances by category, is clean, it's well documented, and it's also well structured. We can summarize the data as follows. The data characterizes geographies, the associated crime category for a given financial year. If the geography is ZA, the count is the cumulative sum of all of the other geographies for the given financial year. Else, so the geography is not ZA, the count is the number of occurrences of a specific crime category for a given year, which is something we proved above. And if you want to prove it for all, you see where I have financial year 2011-2012, change that, and you can also change one of the crime categories. We now begin plotting our data in an effort to gain deeper insights and understanding. It is often difficult to convey information in an analytical format, especially when numbers are involved. It tends to be a little easier, or in some cases much easier, to convey information in a visualization format. Now, Let us grab our crime categories and then run the dot unique method on it. And here are all the unique crime categories. In the first plot, I want to begin by selecting a crime category for the geography ZA, and I want to determine how the data has changed over the years. So why am I choosing this as my first? Well, we already established that ZA is the aggregate sum, or should I say the cumulative sum, of all of the other geographies. So therefore, if the crime count for a given category for the geography ZA decreases, increases, or stays static over the years, we'll have a very good understanding of the general crime trend of South Africa. So the x-axis will be the financial years. The y-axis will be the counts for a given crime category. Let me comment these out. To grab the years, all I will do is grab the entire data frame. I will filter it to where the geography is only equal to ZA, and then I will grab the financial year column and I will run the dot unique method on it. This will give me all unique years, beginning 2011, 2012, ending 2022, 2023. We notice we have contact crime count, which will be the entire data frame, where we will then filter it so that geography is only equal to ZA, and crime category is only equal to contact crimes. We will then grab the dot count column, and then we'll grab the dot values from it. Here I'm just altering the figure size. I am then rotating my labels 90 degrees on the x-axis, because if I did not do this, the labels may merge or appear as though they are merging with each other. They will overlay. I will then run the plot function, passing in years as my x, contact crime count as my y, and then my line structure, which will be circles with a solid line, and they will be blue in color. I will then pass in a X label, which is financial year. My Y label is count of crimes of various categories, and my title, count of crimes of various nature in South Africa over years. I have a legend here, but that will become more significant when we uncomment these four out. And here we go. Here is a very good plot. CC just stands for contact crimes. Here's our data with the x-axis, the y-axis, the title. X-axis is the financial year. And the y-axis is the count of crimes for various categories. In our case, we know that this blue line in the top right corner means CC. CC is just shorthand for contact crime. And let's look at the data. Even without me saying anything, you can understand what's happening here. We notice that initially, for the year beginning 2011-2012, we have a count just below 620,000 number of incidents for the crime category contact crimes. We see something good. We see initially a decrease, which is what we want, followed by something we do not want, a significant increase over the next 4 financial years. We again see something good, a decrease from the year beginning 2015-2016 all the way to 2017-2018. Again, this is great. This can be signified by many things. A more active police, greater government intervention, better security measures taken by people, and so on. We again notice something we do not want to see, and that is a pretty steep increase from the year 2017-2018 all the way to 2019-2020. Another steady increase. We notice that initially we start at some point, we initially decrease and we increase. We initially decrease and we increase. That seems to be the trend. And then something very weird happens. For the financial year beginning 2019, so here, ending 2020, we noticed a huge dip. A huge dip. Look at that line. In the number of crimes committed for the crime category contact crimes. Why do you think that is? I'll give you some time. Why do you think that despite this trend showing that we see increases and decreases, nothing before seen of this type, of such a large decrease? Why do you think that is? Let's ignore that for a moment. After that, for the financial year beginning 2020, ending 2021, we see a steep increase for 2 years in a row, 2020, 2021, and again 2021, 2022 to 2022, 2023. A large increase here. So again, we initially saw a very big decrease followed by 2 years of a very large increase. And in fact, if we uncomment these four out, which is the same thing as contact crimes, but in this case I switched the crime category for sexual offenses, crimes detected as a result of police action, aggravated robberies, and contact-related crimes. And now if we run it, here we go. Now we see a better illustration consisting of all our data, where SO with the red line signifies sexual offenses, a cyan line with a star, so this one, should be the crime count for crime associated with the category crime detected as a result of police action. ARC is aggravated robbery. CRC is contact-related crimes, which will be signified by a yellow line. And if we notice something that we want to see is that active policing, so the cyan line, is actually increasing, which is something we want to see. It's great. Shows an active police force. But again, notice the financial year 2019, 2020, 2020, 2021, so the data that pools here. All of the crime categories saw a decrease. Why do you think that is? Following that year, we see that every crime category, excluding aggravated robbery, increase. Why do you think that is? So if we want to shortcut what we did, we will just create a dictionary where the keys will be the crime category and the values will be their line style. If we then keep everything the same and we run a for loop and we run this, we get back the data. Let me see if I can make this a little smaller. I gotta zoom in. Okay. There we go. We now see we get 1, 2, 3, 4, 5, 6, 7, all of our 7 crime categories plotted. And for all of them, for the financial year beginning 2019-2020, ending 2020-21, we see a pretty significant decrease, followed by an increase for all but property-related crimes and aggravated robbery. We can ignore this. We can ignore this, and we come down here. What can we say about the above visualization? Without any order, these may not be mutually exclusive events. Well, it's difficult to know if a crime, such as rape, will fall into the crime category of sexual offense and contact crimes and contact-related crimes. Or will they remain mutually exclusive and will only be recorded as a sexual offense? Unfortunately, there's no way for me to know from this data. But again, I would assume no. I would assume a crime committed can fall into several categories. And if we come down here, it's actually what I said. A crime may fall into multiple categories depending on a multitude of factors, such as severity of the actions taken. It would be difficult to estimate the number of non-overlapping counts of crime. We noticed the period 2019-2020 to 2020-2021 saw a decrease in every crime. Why may this be? Again, government action, stronger policing, more active policing? I would say no. What actually happened is something that you'll see in every country that was hit by COVID-19 and was forced to mandate a government-wide lockdown. If people are locked down, crimes will decrease. Simple as that. So in that case, you can say government intervention at best. Post-lockdown, what we expect to happen happens. Notice it. Let's go up. If I uncomment these out, should I say comment these out? If I run my function, if we say this is the effects of COVID, post-COVID, what happens is something would happen in every country. We would see an increase in the number of crimes committed. But what we not expect is to see a value much higher than the previous highest. Look, prior to COVID, the highest number of contact crimes we had was for the financial year 2015-2016, at a value just above 620,000. Post-COVID, in the financial year 2022-2023, we see a value far above 640,000, nearing 660,000. There could be differences to account for, obviously, an increase in population, a greater, or should I say, a greater number of people living closer to the poverty line and therefore having to resort to crime. Also, maybe it's not the best thing to justify crime. So that's that. Let's come back down here. Post-lockdown, what we expect to happen happens. Every crime category, excluding aggravated robbery and property-related crime, increased. The category contact crime saw a large increase, now sitting at a level higher than ever. This does raise a few questions. Why was the government and all of its security entities, so all armed services who are meant to serve and protect, unable to take advantage of the situation and maintain order? So here's the thing. COVID caused a decrease of crimes. Why was the government not able to at least maintain some level of order post-COVID? Because again, we did not see an increase to levels we had seen before. No, we have seen an increase to levels we have never seen before. Not in all categories, of course, and initially that's what you would say. But if you come down here to this graph, you will notice that even post-COVID, majority of the crime categories are now at a lower state than they were pre-COVID, which would be true for, let's see, poverty-related crimes and other. They are much lower than what they used to be. For crimes such as contact-related crimes, they seem to be at a pretty same level, so that's okay. Aggravated robbery is at a much lower level, even post-COVID. Sexual offense crime seems to be at a static from where it started and where it ends. So initially, if we just had this data, there's what we could say. The government was not able to put into action that which would be required to maintain order. But once we see more data, we notice that no, that's not the case. Majority of crime categories are either falling or staying stagnant, which is fine. Then we can say, why did some crime increase and some decrease? Obviously, post-COVID, some crimes will increase, such as contact crimes will increase. but crimes such as property-related crimes probably wouldn't increase. What I would have expected to increase would have been the sexual offensive crime, but it seems to be at a similar position regardless of the year. Now I will save this and we will carry on it in another video.